Good morning. You're going to have a test on design of experiment, and it's very similar to the quiz. So I'm going to go over the quiz questions with you, and I hope that you'll use this as a review. So because of concerns about employee stress, a large company is conducting a study to compare two programs, Tai Chi or yoga, that may help employees reduce their stress level. Tai Chi is a 1,200-year-old practice originating in China that consists of slow, fluid movements. Yoga is a practice originating in India that consists of breathing exercise and movements designed to stretch and relax muscles. The company has assembled a group of 120 volunteers to participate in the study during the first half of their lunch hour each day for a 10-week period. Each volunteer will be assigned at random, so we're telling us they're assigned, therefore we're working on an experiment, to one of the two groups or to a control group. So this means we have two groups plus one, so we have a total of three groups. So we're going to have Tai Chi and yoga, and then we're going to have a control group that will not be engaging in any exercise program. So the control group is acting as a baseline. Volunteers will have their stress levels measured just before the beginning of the program and 10 weeks later at the completion of it. Diagram a completely randomized design. Whenever I see completely randomized design, I sit there and go, hey, I'm going to place everyone's name in a hat and I'm going to draw for the 120s employed using the three different groups and showing the number of people in each group. So I need to show how many were in each group this time. So the diagram is fairly simple in this case. We're going to randomly assign 120 subjects, 40 to yoga, 40 to Tai Chi, and 40 to no exercise at all. And then we're going to compare stress levels. They did not tell us, we did not need to explain the random allocation, so we didn't need to say we put everyone's name in a hat. We didn't need to tell them that. And we also didn't need to go into the comparison of results. If you just said compare results at the end, that is fine too. But the main thing is you had 120 subjects, you divided it into three groups evenly, so that's 40 per group, 40 to yoga, Tai Chi, and no exercise. If you went in a different order, that is fine. The main thing is that you have those three different treatments. All right, I'm going to pause this for just a second. Okay, scenario 2 is a continuation of the first scenario. So concerned that stress might be gender related, the company for the above scenario, the company decided to block by gender. Remember, when we block, we're breaking it down by something that they already are. So in this case, we're going to block by gender. So we're going to block male and female. Diagram a randomized block design for the 120 employees, which accounted for gender, and utilize the three different groups, being certain to show the number of people in each group. So once again, we're still starting with 120. We're going to have three different groups. They're going to receive yoga, Tai Chi, and none, just like we had above. So, but we're going to start off by blocking. So, diagram only. You do not need to explain the random allocation, nor do you need to explain the comparison of results at the end. So we started off with 120, and we're going to block by gender, and we're going to end up with 60 male and 60 female. And as long as you showed that where they went, you're good to go. Then you're going to randomly assign, and you're going to randomly assign to yoga, Tai Chi, and no exercise. So 20 will go to yoga, 20 will go to Tai Chi, and 20 will have no exercise. So we started off with 60 male, and we split into 20, 20, and 20. And then on the females, we had 60 females, and we split it by 20, 20, and 20. Once again, the order doesn't matter. And at the very end, we're going to compare the stress levels. If you have your arrows facing in different directions, that's not a big deal. The main thing is that you have male and female, because you block by male and female and split them. Then you randomly assign to yoga, Tai Chi, and no exercise. Yoga, Tai Chi, and no exercise. And at the very end, you are going to go ahead and compare results. Okay, scenario 3 is a completely separate design from the previous two. And so we have a cooking class which is trying to determine whether or not chocolate chip cookies made with margarine or butter would be preferred. The class decided to create a match pair design and create the cookie challenge. Remember, in a match pair design, this is really important, people receive both treatments, all right? People receive both treatments. We just randomize the order in which they receive it and create the cookie challenge. So create a diagram for a match pair design for 90 students, which accounts for the cookies made with butter and the cookies made with margarine. Be certain to identify the number of people in each group. So if we have 90 people, we're going to divide it by 2, and we're going to have 45 in each group. So I'm going to start off by randomly allocating the 90 subjects. I'll probably put their names in a hat, and I'm going to draw. 45 would receive treatment 1, and 45, then they would go on and receive treatment 2. So they'd start off with a butter cookie, and then they may switch to the margarine cookie. The other one would start off with a margarine cookie, then they'd go to the butter cookie. And the reason you do that, the reason you switch the order, and it does matter, is I don't know about you, but whenever you go have that very first Krispy Kreme donut, the very first one is delicious and it's awesome, and it's just, fantastic. But by the time you get to the 6th one, not that I would eat 6, but if you did, by the time you get to that one, they don't taste nearly as good. So order does matter when it comes to something. So basically, you want to order so that you control for the time that you taste it. So basically, we have a match pair design. We swap the order, and we have everyone being tested twice. Remember, match pair, you're swapping the order. And this says compare stress level. That's not what we're going to compare. We're going to compare taste. All right, we're going to go ahead and compare taste. We're not going to compare stress level. All right. So that's the match pair design for making the cookie. Okay, scenario 4. Here we have a diagram, and we're going to analyze the information in the diagram. So 2 new pain-relieving medicines for rheumatoid arthritis are being developed, and the following experiment was designed prior to approval by the FDA. So in our diagram, we see that we're going to block by gender because we're going to have male and female. Then we're going to randomly assign. We're going to have drug A, drug B, and a placebo, which will act as our control group. So what is the purpose of the placebo in the above design? And I just kind of gave you a hint to it. The purpose of the placebo is to provide a baseline or to act as a control. So to provide a baseline for pain level by controlling for outside variables that may affect pain level. So the purpose is to control for outside variables that might affect pain level. Because we know that, for instance, weather can affect arthritis pain. And by not providing the medication in one group, a baseline for pain is established, which provides a comparison to determine whether the drugs were reducing pain regardless of the effects outside. The part that's highlighted is important. That's what you need to have. The purpose of the placebo is to provide a baseline for what? For pain level by controlling for outside variables. All right? Or you can say it provides a baseline to determine whether or not the drugs are working. So if you want to make it really simple, provides a baseline to control for outside variables so that we'll know if the drugs are actually working. All right? Just to provide a baseline. I can't get that word out enough. All right. Could this experiment be performed double blind? And the answer is yeah, it could be performed double blind because neither the data collector nor the subject needs to know which drug they're receiving. All right. So we could disguise what drug they're receiving. So you need to say could be performed as a double blind, and neither the data collector nor the subject needs to know whether or not they're receiving drug A or B or the placebo. All right. Now, whether this is an oral medication, we could have A, B, and C. A could be the old drug, B could be the new drug, and C could be a sugar pill or something like that. If it's an ointment, A could be the old ointment, B could be the new ointment, and C could be some sort of fake cream that has nothing to do with it. All right? All right, the next thing. Explain how one could perform random allocation. In other words, random assignment. All right, random assignment. Well, we have 3 different groups, and we happen to have 480 people. All right. So we have 960. So we're going to place the 480 males in a hat and mix. Their first 160 names would receive drug A. The next 160 would receive drug B. and the remaining 160 received the placebo. We would do the same for the females. Notice we started off with 960, and I divided it by 2, so I'd have half males and half females, because remember, we started off by blocking. So I blocked, and I had 480 males. I put their name in a hat and mixed. The first 160 got drug A, the next 160 got drug B, the remaining got the placebo. I put the 480 females in a hat and mixed. The first 160 received drug A, the next 160 received drug B, and the remaining 160 received the placebo. So, and if you sit there and you said, hey, I did it on females first, and then I said male, same for males, perfect. All right, outstanding. All right, let's go ahead and pause for just a moment. All right, the next thing says explain the comparison results. Well, what were we looking at? We were looking at pain levels from rheumatoid arthritis. So patients report their pain levels on a subjective scale, and the levels of pain for drug A, B, and the placebo would be compared. In other words, all you had to say is we're going to compare pain levels at a certain amount of time. We're going to administer the drugs, and after an appropriate amount of time, we're going to see how much pain they suffered. How many could be assigned to each treatment? Well, how many treatments do I have? When I look at this, I go 1, 2, 3, 4, 5, 6 treatments. So I have 6 treatments, and I have 960 people. So 960 divided by 6 is 160, and that would be my answer. 160 would be assigned to each treatment. It asks for the response variable. The response variable is what we're comparing at the end, and what we're comparing at the end is the level of arthritis. Then it says, what are the explanatory variable or variables and their levels? So let's look back at our diagram. Well, that's an explanatory variable, and this is gender. And then it has 2 levels. And then right here, it's the drug, and we have 3 levels. All right? So we have gender with 2 levels and drug with 3 levels based on the diagram. The next thing it asks for is list each treatment, and this gets a little bit long. So we have the male treatments, and we have male drug A, male drug B, and male in the placebo. Conversely, we have the female drug A, female drug B, and female in the placebo. So I should be listing 1, 2, 3, 4, 5, 6 different treatments with all those combinations. So it should look something like this: male drug A, male drug B, male placebo; female drug A, female drug B, female placebo. Or for those of you who like to abbreviate, and that's fine, make sure it makes sense: male A, male B, male placebo; female A, female B, female placebo. Either one of those would be absolutely excellent. All right, we're beginning with scenario 5. A student group was interested in the effectiveness of 3 acne medications and designed the following a completely randomized design. So we're going to randomly assign to 3 groups, and we have three medications: Proactiv, Clearasil, and Equate, and then we're going to compare results. So what is the response variable? Well, if we're looking at acne, we're probably looking at how clear your face is or the number of zits. So if you want to say the response variable is the number of zits, that's fine, the number of pimples, or how clear your face is, any of those would be acceptable. The explanatory variable in this case is the drug, and we happen to have 3 levels: Proactiv, Clearasil, and Equate. So when we go to list our treatments, it's very simple: Proactiv, Clearasil, and Equate. And we have 1, 2, 3 treatments, and we can see that on the diagram, because this is treatment 1, treatment 2, treatment 3. Okay, this is scenario 6, and we have a diagram to analyze and discuss. So a group of medical researchers designed a study to determine the effects of a certain lifestyle choices and medication on blood pressure. All right, could this be performed as a double-blind or only a single-blind experiment? Examine or justify your responses. First off, let's look at this. So we're blocking by gender. So we have male and female. Then we're randomly assigning to a random assignment to a low or high sodium diet. And then we're randomly assigning to a exercise treatment program. So we have 30 minutes daily, 30 minutes 3 times a week, and then no exercise. So let's real quickly look at our variables. So right here, we have one variable, which is gender. We have another variable, which is sodium. Then we have another variable, which is the amount of exercise. So in total, we have 3 separate variables. This one has 2 levels, male and female. That does not look much like a 2. This one has 2 levels, high and low sodium and high sodium. And then the exercise has 3 levels, daily, 3 times a week, and no exercise. Well, the question is, could this be performed double blind? Well, remember, to be double blind, neither the data collector nor the person who's a member of the experiment knows their treatment. Well, the fact of the matter is, when I get over here to these actual treatments, well, I should back up. On the sodium, I may not know, the data collector and the person being studied may not know whether they have a high sodium or low sodium. That might be able to be disguised. The data collector will not know necessarily how much you exercise, because all they're doing is they're just checking to see what your blood pressure is. So at the end of the day, they're just checking your blood pressure. So they may not know what's going on with it, what your diet is, whether you're exercising. So the data collector might not know. But believe me, I'm going to know if someone made me exercise. Okay, if they pull me off the sofa, I'm going to know. So consequently, this could not be double blind, because the person who's receiving the exercise treatment is absolutely going to know. So this experiment could be performed as a single blind experiment, but not as a double blind. The data collector would not know the sodium level or if a subject or the subject's exercise level. But a subject knows their exercise level, so they cannot be blinded. So the subject cannot be blinded, but the data collector could be. So single blind, because the data collector would be blinded, but the subject would not be. All right, the next thing, explain the comparison of results in context. Well, what are we looking for to compare at the end? Well, we're looking to compare, according to this, they said we're looking for blood pressure. So we're going to compare how high blood pressure is, or the average blood pressure for each treatment will be compared. So basically, we're going to compare blood pressure. My response variable, well, that's very simple. We just answered that. That's blood pressure. And then my explanatory variables, we kind of broke those down already. All right, we broke those down already. We have gender that has 2 levels. We have sodium level, which has 2 levels, and we have exercise, which is 3 levels. All right, so we need to list those. And we're just going to list them as gender 2 levels, sodium 2 levels, and exercise 3 levels. And then finally, we need to list each treatment. We have a lot of them, because when I look at the end, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 treatments. And once again, 2 times 2 is 4, times these 3 is 12. So I have 12 treatments, and it asks me to list each one. So we're going to have, on the male side of things, we're going to have a male, low sodium, and then daily exercise. Male, low sodium, 3 times a week. Male, low sodium, no exercise. And then you're going to do male, high sodium, same thing. Then you come to the females. You have female, low sodium, 30 minutes daily. Female, low sodium, 3 times a week. Female, low sodium, no exercise. And then you'll break it down the same way for the high sodium side. So you need to list all of those. When I do that, it looks something like this. Male, high sodium, daily. Male, high sodium, exercise 3 times a week. Male, high sodium, no exercise. Male, low sodium, daily exercise. Male, low sodium, 3 times a week. Male, low sodium, no exercise. Female, high sodium, daily. Female, high sodium, 3 times a week. Female, high sodium, no exercise. Female, low sodium, daily. Female, low sodium, 3 times a week. Female, low sodium, no exercise. And if you wanted to abbreviate those some way, that's fine. So you could have done something like this. Male, high, daily. Male, high, 3 times. Male, high, 0. All right? But please make them in nice, neat columns. I know that's not a neat column, but do make them in nice, neat columns so it makes it easier for us to grade. All right, but it's perfectly acceptable to abbreviate. If I were abbreviating the females, let's just say I wanted to abbreviate those, I could go female, high, daily, female, high, 3 times, female, high, 0. Then female, low, daily, female, FLD, FL3, FL0 would take care of that one. All right. Okay, please note that your test is going to look very, very similar to this. If you know how to do this, you should do very well. I would highly recommend you taking a time and practicing this, and we'll provide you with one to practice with. Thank you.